Hello everyone, I'm Binta. Welcome back to another video. So in this video, I'm going to be talking about functions. Alright, so functions is a brand new stuff to actually know. Alright, because there are a lot of rules inside and there are a lot of different things that you can do with a function. Alright, so first thing we are going to know what defines a function. A function is defined when every input has only one output. All right, so this is the first rule to be defined as a function. All right, so in maths later on, we will learn about a lot of different type of graphs. It's like one to one, many to one to many, and so on. But I don't think it's covered in maths, so I'm not gonna talk about it first because this video is for maths. All right, so what we're gonna learn in functions are we are first gonna learn how to denote a function, all right, and then after that we will learn how to find inverse of a function, all right, and then we are gonna learn how to find composite functions. All right, so we're gonna this is the agenda for the video today. All right, I mean in this video. So first thing, we're going to learn how to denote a function. All right, let's draw a line. All right, denoting a function can be denoted in two ways. All right, uh, in two ways. All right, you can denote a function of x. All right, fx is equals to I mean, this is the normal one, 3x plus 1. All right, so this is the original type to denote a function by equals. All right, by the use of fx. The second one here, we are using f dot dot x. All right, this is a little bit special because the function of x can be denoted. I mean, you want to add a little thing here, it's okay. All right, is denoted as 3x plus 1. You can denote the functions in either way. All right, it actually makes no difference. All right, but for video purposes and for habit, I will use this. All right, I will use this a lot more. All right, so this is one thing about the function. And then before finding an inverse function here, we are gonna be doing I will introduce to you domain and range. All right, so what's a domain and a range? All right, how many spaces do we have here? All right, so to shorten things down, domain is actually what's this? All right, domain is actually equivalent to your input, and range is actually equals to your output. Nothing else special. All right, it's just like this. So when a question gives you a domain, then you need to make sure your range is according to the domain. All right, let's say for eg fx is equals to 3x plus 1, and the domain is given x is 0 to 3. All right, therefore if you are to find the range, okay, if you have to find the range of fx will be actually equals to range is dot dot fx is lesser or is more or equals to 1 and more or equals to and lesser or equals to 10. All right, so this is the domain and range. So when the question gives you a domain, your range must be according to the domain. All right, so the next part here, we are going to be learning how to find an inverse function. All right, so what is an inverse function? Okay, so from here, let's say you have a set of values. All right, your set of values here, you have 1, 2, 3. All right, and then this is through fx, and this is your domain, this is your range. All right, so from here let's say your fx is equals to 3x plus 1. Therefore, you will get your answer here to be 4, 7, and 10. All right, so this is a domain and a range. So from domain, through the function fx, you get your range. So what is an inverse function? All right, so an inverse function is basically getting back from the range to the domain. All right, so this is an inverse fx. All right, so how do you find an inverse fx? All right, so there are a lot of ways out there, but I'm just gonna introduce to you my way of finding the inverse. All right, because I think this is one of the easiest one and one of the not so complicated ones. All right, so how to find an inverse function? All right, so first thing we're gonna go for a linear one first, a linear function. So fx is equals to ax plus b. Okay, so how do you find the inverse? So we're gonna do step 1. Let y equals to fx. All right, so we will change this whole thing to y is equals to ax plus b. Okay, then we have step number 2. Make x the subject. All right, so if you don't know how to make something a subject, please check out the video. I think it's the first video for algebra that I talk about how to make something the subject. All right, so you are to make x the subject, then it's equals to ax is equals to y minus b, and x is equals to y minus b over a. All right, then your last step here, step 3. All right, then you can make x you can I mean you would just strictly change x to inverse fx and y to x. All right, so there is actually a theory behind this, but for I mean you don't need to know so much. If you really want to know why you can just change like that, you can go to other videos. Just for here, I will just tell you the 3 simple steps so that you can find the inverse uh as fast as possible. All right, because in exams, to find an inverse, you need to be very fast on finding how the inverse is. All right, is equals to x minus b over a. So this is how you look for an inverse here. All right, then it will just make back from the range to the domain. All right, so if fx here, all right, the domain is there's something to take note here. All right, no, no. All right, the domain, all right, domain, mm, let's take the other colors. All right, domain of fx is equals to the range of inverse fx. All right, and then vice versa, the range of fx is equals to the domain of inverse fx. All right, because if you look from here, right, domain is the input and the range is the output. From the input, we go through the function fx, we get the output. So the input for the inverse fx is actually the range of fx. So this is how it works. This is one thing that you need to remember. The domain of a fx is the range of inverse fx. All right, so this is how you find an inverse for a linear function. All right, so the next thing here I'm going to talk about is how to find an inverse for quadratic function. All right, so how how ish, I know something is wrong. All right, how to find inverse for quadratic function. All right, So we know that a quadratic function is given by fx is equals to ax squared plus bx plus c. So this is the general form. So step number one, you are to still let y equals to fx. All right. So in order to look for inverse functions, your first step is always to make y equals to the whole thing. Y equals to fx. So this is the first part. All right. So the second step here is a little bit different. All right, because you need to make x the subject. So if you are to make x the subject, you have a term of x squared and a term of x here. So there's only one way, if you already have that in your mind, to make only one term of x is step number 2, complete the squares. All right. So after completing the squares, you will get something like all right. So to save time and save space, I just copied this from after I did it on the paper. All right. So after you complete the squares, you will get y is equals to this following here. All right. If you want to double check, you can go back to the previous video where I talked about how to solve a quadratic equation. All right. So I proved that you will get until this line. So from here, all right, in order to make x the subject, we will combine this to 1 first, b squared minus 4ac. Okay. So your next thing to do here is the same as the previous one. Step 3, make x the subject. All right, so this is the additional step 2 to complete the squares here. If you are to look for the inverse for a quadratic function. All right, so from here you will get y plus b squared minus 4ac divided by 4a is equals to a bracket x plus b over 2a squared. All right, and if you combine this two and bring the a down, so you get 4ay plus b squared minus 4ac. Let me double check. 4ay plus b squared minus 4ac, and then you bring the a down is equals to x plus b over 2a squared. Okay, so from here you will need to bring the power x plus b over 2a is equals to cert plus minus 4ay plus, all right, 4ay plus b squared minus 4ac divided by 4a squared. All right, and then to further continue here, okay, you will get x is equals to negative b plus minus cert 4ay plus b squared minus 4ac divided by 2a. All right, and then lastly, the step 4 is the same as the ones before. Step 4, x2 f inverse x and y to x. All right, so from here we know that the inverse x is equals to negative b plus minus cert 4ax minus 4ac plus b squared divided by 2a. All right, so this is how you look for an inverse. All right, you don't need to look at all these unknowns here. You just need to remember the steps. All right, you let y equals to fx, you complete the squares, you make x the subject, and step number 4, you change the x to f inverse and y to x. All right, so after this, the next part here, we're gonna talk about composite functions. All right, so composite functions. What are composite functions? Composite functions are when two functions join together. For example, e.g., all right, given in the question, fx is equals to 3x minus 5 and gx, all right, is given x squared. All right, so you are to look for composite functions. So composite functions is like find fgx. All right, so when you have an fgx here, how are you going to look for fgx? Okay, so this is not too hard. All right, so first step here, fgx is equals to f bracket gx. All right, so this is the first part you need to do. Then the second one, you will sub gx inside, so it's fx squared. All right, then lastly, from here, when it's fx squared, you just need to change the x to x squared. Then you will get 3x squared minus 5. All right, so from here, why can you just substitute that in? All right, because if you see from here, fx is equals to 3x minus 5. When you sub f equals to 0, you are subbing 0 as the x. All right, so if you are to fx squared here inside, then you are just going to put x squared. You're going to sub the x as x squared. All right, so I hope you get what this means. All right, so this is the first example here. Then we have the second one. All right, we can also, the question can also ask you to find gfx. All right, so gfx is equals to, all right, it's the same procedure as the one above. You're gonna first substitute the fx and then sub the whole thing inside the function of g. All right, so fx is 3x minus 5. You will get equals to g 3x minus 5. All right, and then gx is equals to x squared, but now you are going to substitute this into x squared, so it's actually 3x minus 5 squared. All right, so this is the factorized version. If you are to expand this by the formula, you got ax squared minus 2ab plus b squared. All right, so this is how this is what you will get if you expand this out. All right, so this is the first two easier ones. All right, and now this is the easier one that maybe it's only gonna cost 1 or 2 marks. All right, so from here, I'm gonna write again the next one. This is the another scenario, all right, where question given here. All right, the title here is find fx or gx given fgx. All right, so from here we're gonna first scene eg number 1, eg1. All right, it's given like just now, fx is equals to 3x minus 5 and fgx is equals to uh fgx is equals to what's this, fgx is 3x squared minus 5, 3x squared minus 5. So the question will ask you to look for find gx. All right, so this in the first case here, to find gx, if gx is the first like the function that you are gonna process first, then it's gonna be easy. So from here we know that f gx is equals to 3x squared minus 5. So from here, if you are gonna look for gx, all right, so f bracket gx is equals to 3x squared minus 5. Okay, so from here, if you are to compare with fx, all right, the difference is the square here. So we know that by comparing, gx is equals to x squared. All right, because by subbing gx into f, the function of f, you get 3x squared minus 5. And if you compare to the function of the fx, you will just get the x, and x squared is the only difference. Therefore, you know that gx is equals to x squared. All right, so the second scenario here, e.g. number 2, you are still given fx, all right? Fx is equals to 3x minus 5, but now you are given gfx instead. is equals to g of x is equals to uh 3x minus 5 squared. 3x minus 5 squared. So how are you going to look for this? All right. So the question asks you to find gx. So this is going to be a little bit hard here. All right. Of course, you can use the compare method, but usually it's not going to be so that easy to compare. So from here, you will need to use gx is equals to g f. Oh, why do I use the color? All right. Gx is equals to g f inverse x. All right. How does this work? Because if f and f inverse x is equals to x, basically nothing. All right. Because where can I write this? Okay. From here, you can see that. All right. If this is x and this is y, all right, if you have fx and uh, f inverse x, all right, so f inverse first, from y you go back to x, and then fx again you go back to y. So if it's anything like this, then you will still get back the original one. Therefore we can say that f inverse x is equals to x. All right, so this is one result that you will need to remember. Okay, so it's equivalent, but now you are given gfx is this, and so you will need to look for fx first. So inverse fx, how do you look for inverse fx? All right, so by doing the steps just now, you will know that you need to make f or y equals to fx, and then you make x the subject, so you will get x plus 5 divided by 3. All right, so from here, you know that gx is equals to gf bracket f inverse x. All right, then you will know that gf bracket x plus 5 divided by 3. All right, and then you are to sub this x plus 5 divided by 3 back to the gf given. All right, so it's equals to 3. The x there, you are to sub this 3 bracket x plus 5 divided by 3. All right, minus 5. Okay, 3x squared minus 5, and then the whole thing squared. All right, then from here you will get the answer is equals to x squared. All right, and so this is how you look for oh no, this is so ugly. All right, and this is how you look for one missing function from given a composite function. All right, maybe I will find fx or gx given all right, it's given gx or gfx. All right, so this is one very important thing that you need to know how to do for functions. All right. So before I end this video, all right, this is actually all about function. So I will need to write a few notes here, all right, that you need to take note. All right. From there, we found out that a few results. F inverse x is equals to inverse fx is equals to x. All right, so any value that you get from f inverse, you will get back the same value. For example, e.g. f inverse 1, you will be equals to 1. All right, that's it. So this is the first note, and then the second note. All right, there's a rule here for composite function. For composite function, all right, for composite function, let's say fgx. All right, you are to do g before you do x. So the rule is as so. All right, this is very important rule. Fgx exists only if, all right, the range of gx is a subset of the domain of fx. All right, so how does this work? All right, because why does this work? Yeah, why does this rule exist? So you know that from here, all right, from A to B to C, this is FGX. FGX, from A to B, you are this, and then from B to C, you go through Fx. So if the range of Gx, all right, if the range of Gx is larger than the domain of F here, then this composite function is not valid, right? Because the domain here cannot be smaller than the range there. So what you can do here is, if the range of this gx is smaller than the domain of fx, only this composite function will work. All right. So if you don't understand what I just said just now, you just need to remember this thing. All right. The range of gx is must be a subset of domain of fx given fgx. All right. So the range of the inner one must be smaller or equals to the domain of the larger one. All right. So these are the two things that you need to take note of it. And yeah, with this marks the end of the video about function. So this is a new thing to learn if you have not seen anything like this before. And we're gonna use function a lot in the future, especially in maths. We're gonna have a lot more difference like domain, core domain, uh, and a lot of stuff. All right. So yeah, with this, I'll end this video. In the next video, we're gonna look for how to sketch graphs. All right. So yeah, thank you for watching and stay tuned for the next video. Thank you.